Plus One Engineering was challenged with the task of creating a new practice basketball facility for San Diego State University. This facility is to be located at the historic Aztec Bowl, adjacent to both the Aztec Recreation Center and Viejas Arena. The development of the facility utilizes a wide range of civil engineering disciplines. For this project, major emphasis was placed on our primary disciplines of structural and environmental engineering. In addition, secondary disciplines were considered to produce a realistic design of the facility. These included geotechnical, transportation, water resources, and construction engineering.
The main geotechnical considerations included completing a geotechnical report and designing the support for the west wall of the Aztec Bowl. The project geotechnical report includes an analysis of the on-site soils, the area geology, and a fault investigation. The soils we identified on the site included stadium conglomerate throughout the site, with pockets of Mission Valley Formation overlying the conglomerate. Laboratory tests included a standard Proctor compaction test, a direct shear test, and a sieve analysis. For the slope stability portion of the project, we originally rejected the concept of using a retaining wall since it was not feasible to cut the slope and then build the wall. We also rejected a soil nail wall concept because it lacked the strength to retain the stadium conglomerate safely. The stability structure, which turned out to be most effective, is a soldier pile with tieback structure on the 200-foot-long, 55-foot-high wall face between the Aztec Recreation Center and the basketball practice facility. This structure passes with a factor of safety of 1.6.
The structural scope included the design of a 33,000 square foot basketball practice facility, which contains a 25,000 square foot footprint and an additional 8,000 square foot mezzanine level. The structure contains 2 full-size college basketball courts with a 10-foot clear perimeter and the 35-foot clear ceiling height. The building is a steel frame structure that utilizes a composite beam roof system to support the 100 pounds per square foot dead load created by the green roof. The design was initialized by modeling the building using ETAB software. This program enabled me to get a general feeling how the building would perform under the loading conditions and provided initial size estimates for the framing. Additionally, 4 8-foot-deep girder trusses were used to span across the court areas. The truss configuration was analyzed using RISA software. The resulting axial forces were used to design the girder trusses. The top and bottom cords are made of 15-inch deep WT sections with HSS 6x6 tubes used as the web members. I began the design of the lateral force resisting system by attending a seminar presented by the Structural Engineers Association of San Diego and received the 2009 IBC SEA OSD Structural Seismic Design Manuals. The rigid diaphragm design added unanticipated complexity to the system that I was able to work through using the manuals and advice from industry professionals. The foundation system contains a 5-inch slab on grade with spread footings at the gravity load columns and grade beams at the brace frames. A 7,000 pound per square foot soil bearing pressure was provided by the team's geotechnical engineer. Design is both efficient and able to withstand the loading conditions provided by the heavy roof system and the high seismicity of the area.
With site visits, some given information, and viable assumptions, a hydrology report, water report, and a stormwater pollution prevention plan were all created for the San Diego State basketball practice facility. The hydrology report was generated based on the existing drainage basins and the proposed drainage basins. A standard design criterion was used to determine the site needs, and we wanted to ensure the site would withstand a 100-year flood. New storm drains were placed in the various proposed basin areas, and each pipe size was analyzed and calculated using HydroFlow storm drain analysis program. From the data we inquired, we were unable to determine the exact properties of the existing water line. Therefore, the size and location of the pipe was assumed to be 8-inch PVC, and starting from the south side of the property, running northeast towards parking structure 4. Our final designs incorporated all the given information and many assumed values. We have stated all of our assumptions in our design reports. Our assumptions were based on discussions with industry, professionals, research, and available standards to help us determine reasonable values.
The environmental section of this project focused on putting together a green roof and doing a LEED checklist. For those unfamiliar with LEED, it stands for Leadership in Energy and Environmental Design. The green roof was the main point of focus for this portion of the project. Our building has an extensive green roof with a depth of 4¼ inch live roof units. These units account for the stormwater collection, filtration, and provide all the perks of a typical green roof. They will also save a lot of time for installation and will be 90% vegetated from the day they are installed. Our roof will have over 20,000 square feet of vegetated area and require little water to survive. However, an irrigation system will be installed for the long periods of dry weather we have in San Diego. The green roof will also have 5,075 square feet of solar panels to help offset some of the building's energy requirements. For LEED certification, it is important to produce at least 13% of the building's expected energy consumption. Our building's projected consumption is approximately 500,000 kilowatt hours per year. To be on the safe side, we designed a system that will produce 75,000 kilowatt hours per year, or 15% of the total energy for the building. These solar panels will run along the center of the roof from the west to the east and face south to collect the most sunlight. Our building is designed to receive the highest rating available from LEED, Platinum certification. This building as designed should receive 88 points, which gives room for potential changes during the building process or discrepancies with LEED.
The parking design and ground-level vehicle access were two considerations made regarding the transportation aspect of this facility. To design the parking lot, the County of San Diego Parking Design Manual and Zoning Ordinance were used as references. Following zoning ordinance regulations, our facility required a minimum of 132 parking spaces. The parking on the actual site is too small to meet the minimum requirements, but additional parking is available just north of the facility in SDSU's Parking Structure 4. The lot utilizes 90-degree parking spaces with 9 by 18-foot stalls and a 26-foot two-way aisle. In addition, 2 accessible and 3 cleaner vehicle spaces are also provided. The main concern with the facility's ground-level vehicle access is the ability for large trucks to maneuver in and out of the parking lot for events held at Villas Arena. Because the current entrance already allows large vehicles, no changes needed to be made, but auto-turn was utilized to ensure there was adequate space in the smaller design parking lot for the trucks to maneuver.
Plus One's construction phasing plan is divided into 2 phases over an estimated 24-month-long period. For the first 1 to 4th month interval, initial work will consist of construction tasks that include a contractor's laydown, vehicle access development, drainage, and stair demolition. All the while, site analyses occur to prep for the rest of the project. During the 4 to 8th month interval, excavation and grading will begin, along with the construction of a soil nail wall. Material from the stair demolition will also be used at this time. During the 8 to 12th month interval, the Villas Arena water station will be relocated. Utilities from and to the area will be shut off, and pipes will be replaced and tied back into the existing system. The development of the stormwater basins will also begin. At Phase 2, precision grading and foundation installment begins. Structural aspects such as footing, slab, frame, curtain wall, mezzanine, and roofing construction will occur. As the facility nears completion, the parking lot, sidewalk curbs, and gutters will be created. This portion will also entail all of the green roof and solar panel installments, as well as finishing up any above-ground basin installations for stormwater recycling. The projected cost is estimated to be around $15.6 million total. With a 33,000 square foot area, the creation of this facility will cost about $472 per square foot.
With all of these disciplines put into careful consideration, Plus One Engineering can confidently say that this proposed basketball facility is not only realistic, but an exceptional design for San Diego State University.